Today, I'm going to kind of give you a complete understanding of how industry is shaping. Okay, and eventually, the data science course needs to get bit relevant with the course that are kind of been planned in the industry, right? So, I will give you that picture, showcase you three, four uh, applications that are very relevant, and you might have already heard of it, right? And that definitely help us to give us a complete understanding and picture. So first of all, data science is a kind of an aggregation of two things. One is you have the machine learning algorithms or the deep learning algorithms, plus you have a business logic to solve, or you can say business problem statement to solve. So aggregation of two things are important. One is you need to build out very intelligent algorithm. At the same time, you need some of these business problems also to get sorted. So that typically helps us to understand how can you use technology over here to solve your business problem. That is a part of your data science. Now, when you go with any of the curriculum, you see that there are a lot of things that you learn, right? You see, you learn machine learning, you learn deep learning, okay, you learn Python, you learn data visualization, right? Bit of data analysis, exploratory data analysis. So all these are kind of tools to mine out your relevant information from the data. But what is more important is an experience to mine this information out. So that is more important. Okay, means you know the tool, you have those tools. All of these algorithms are predefined. Okay, those are invented in 1952. Some of these deep learning algorithms, they are there from 1952, right? So it is not new to the industry. Statistician used to use these algorithms to solve their challenges. Now industry is shaping. We have a very good programming language that helps us. We have a very good computing mechanism like AWS cloud. We have a proper you can say structure and a lot of open source frameworks which were not being present in 1952 to get those things executed in a real world scenario. So you have the machine learning, deep learning algorithms. The major aspect is to learn the technique to apply these algorithms. Where you should apply, why you should apply, what business problem you are solving, and what is the ROI. Okay. Most of the courses doesn't teach you these insights. Okay. That how to evaluate, how to do the value engineering. Okay. They never teach you. They always teach you the algorithms. But it is more important to understand the ROI, return on investment. You apply so much of algorithms, you apply so much of heavy tools, okay? You take so much of computation cost, but if you don't know how to evaluate the ROIs, then definitely it is not going to help you, okay? So this is one of the factor that we really needed to cater on while we learn how to build and how to solve our business problems. And that is what we are going to learn, okay, in this entire journey of data science. So take these tools, whatever you have, learn programming, apply those techniques, and then get it into a business problem to solve and figure out what are our ROIs. Okay. So until we figure this out, what are our ROIs, we'll not able to actually value add. So I have seen like a lot of data science team, okay, they are into an R&D, but they don't know that their R&D is kind of sucking a lot of money, which typically doesn't, you can say, help in generating more business. So that's where the problem starts, and there could be different situation or scenario. You can only experiment for fewer days, but you cannot keep on experimenting, right? So that's why it is very important to understand that what are the ROIs and then what are the business problem that we can solve it, and how can we solve this out. Okay. So these are the techniques, okay, how to do the analytics. And most importantly, like you might have already seen or know that we are going to take some real world use cases. Okay. So we are going to take some real world use cases. Like one of the use cases that we are currently working is from VMart and Itchior. Okay. They both are the two different e-commerce, or you can say um, the one is e-commerce, which is VMart, and Eatshare is basically a food delivery app. So they have their own way of doing business. So VMart wants more and more sales, whereas Eatshare wants how can they optimize their cost, how can they deliver their product in our respective, or you can say very faster way of delivering it. Okay. So that's what one of the idea over here with these two projects. And what we do is we take the use case, okay? We kind of help you to understand those use case, and then we ask you to solve these problems, which comes from VMart and each year. So you either need to solve this problem out, and then once you complete it, you get those accomplishment and all of those stuffs. So this exposure on real world data is very much needed, rather than you work on any sort of predefined data, pre-processed data, or let's say Kaggle data sets which are pretty much pre-processed, where you don't learn how to do a feature engineering, which is one of the major tasks, right? You don't learn how to do feature engineering because the features are already pre-processed. You just take those features, convert into a some scale, and train your model. So that's not the real world data science is all about. Real world data science is to hustle and generate your features. In most of the use cases, 90% of the use cases, you don't have predefined data set. You need to generate, you need to figure out, you need to generate your own data set, means generate your features out of the data set. It means you will have the contextual data, but you have to generate the feature out of that data set. So typically, data science project takes somewhere around, you might be shocked after hearing this, data science project takes somewhere around 6 months to 9 months to create a baseline model. Okay, baseline model. What we get to see in a day, in 2 hours, anybody can build a regression model. Those are all on the predefined data set. Okay, so remember, predefined data set is already cleaned, already pre-processed, all the feature engineering are done. Okay, everything is already done, so there is nothing to do. You apply the algorithm and that's what you get the result. But in real world use cases, it takes 6 to 9 months to create a baseline model. Baseline model means just to experiment out how your data is performing on this particular algorithm. And after that, you need to go with few more iterations to fine tune this baseline model. Okay, to fine tune this baseline model, and then after you yield your result. So it is not so you can say not so frequently that we build any model. We do a proper evaluation. We go through some engineering principles as well. Okay, that how well our model is getting developed, how well we are able to determine all the pros and cons from the given data set, and then try to figure out the first few things. What are the business challenges? Okay, what are the ROIs after building this model? What in return we will get? How much improvement that I can guarantee and assure? Then after we invest this much amount of time on building the baseline model, and then fine tune within 2-3 months, we fine tune, and we take 1 month to deploy these models into application, or it's a part of the deployment, whether you take it as a service or whether you take it as an application. So these are the steps that you put in, okay, wherein you go ahead and apply all of these logics together and build your existing machine learning or deep learning model sustainable model. Okay, so typically if you see a project takes near about a year. Okay, and then you need another 6 months after spending a year to deploy your model. You need another 6 months of study to understand whether your model is really giving the ROI that you have estimated in the beginning. Okay, so you need near about 1.5 year, okay, on an average, to basically deploy any given models and get your stuffs on a real world phase, right? So now just imagine um, that after spending this much amount of time, if your model fails, so nobody is going to kind of help us with that, right? So that's the reason that what we do is we try to learn the stuffs in a different way. We don't directly jump into the algorithms that are being taught. Okay, we spend a couple of days in understanding different problem statement first, try to evaluate how can we solve the problem, and then we try to do a lot of exploratory analysis. 3 4 months we do exploratory analysis. Okay, that does it support our problem statement. Another thing that we do is try to understand the literature review. Okay, uh, what are the existing solutions that are available in the market? What are the competitors' solution? Are we ahead of that solution or are we behind that solution? So how we are basically building the entire solution. So that is also very, very important because it helps us to identify that how good we are building it. Okay, and also help us to identify and estimate this ROI, right? So typically that the same mechanism that we get to see in a production. So whatever I explained you, this is in a production environment, we follow this in organization level. So here we are trying to actually mimic that. Okay, we are trying to give you that exposure that you learn in a way that you work in an organization, right? So first few hours we are going to learn how to kind of do the basic coding. Okay, those were completely beginner for them. Okay, and then after slowly you jump into the algorithms. Okay, the how to do this exploratory data analysis. We spend a couple of weeks in doing those, and then finally we jump into the learning how do we kind of apply those algorithms. Okay, what are the best case scenarios, and the next is evaluation of these algorithms. Okay, that how do you evaluate each of these algorithms, and how do you evaluate in terms of business the problem that you are solving. Most of you think, or if you know a bit of data science, you will think that accuracy is the one that we most focus on. But accuracy is the untouched or untapped thing that we do in real world production. We focus on precision, recall, we focus on the different other parameters. Okay, which you will come to learn once you attend this course. You'll come to learn those things. That accuracy doesn't matter to us. Okay, what it matters is how much cost that we are kind of putting it, and how much um, effort that we are putting it to get those results correct. Okay, so that is one of the thing that you will learn. These things are a bit different, and you only get to learn in a way not typically as a course, but as an experience. Okay, it's an experience. It's not a course, guys, where you will first learn and then you need to replicate it back. Okay, you need to work, and whatever you have learned, you need to apply those in a real-time environment, and then you need to prove yourself that yes, this is what I am, then a successful data scientist, right? So that is how we prefer. Okay, the typical, this is the difference. Okay, getting an industry exposure on how a model is developed. Okay, how do we evaluate all the techniques, tools and techniques that we say, what all things you will apply. Okay, what all things you will learn. So you just go and apply those, get your results driven out in these projects, as I said, like in VMart and Insure. Okay, so these are the two vendors that we have for whom we can basically help you with their production level data, solve their problem statements, get it deployed, okay, derive out the results, okay, and then you can basically showcase that, yeah, this is the project that I have worked on. Typically what happens, those who are very new to data science, okay, people try to solve Kaggle project. Now when you go to an interview, what happens, they can easily understand that you have worked on a Kaggle project, okay, because your project will match with somebody else's project, and then it will match with another guy's project, so it doesn't create any differentiation. And another thing is, in interview you will have two aspects. One is your technical aspect. Typically the data science interview, they are a bit different than what you get to learn. So one is your programming aspect. All the product based company that you will be working for, they will be heavily dependent on your programming skills. So first is your programming skill, okay, that programming skill not related to data science, programming skill in relation to basic algorithms, okay, basic functionalities. They want to understand, they want to learn from you whether you are good at your basic logical skills or not. So like you do give aptitude test, right, in different other interviews, okay, but in engineering and in this data science interview, this is your aptitude, like programming skill. They never ask you programming related to data science. They ask you programming in relation to different other model building capabilities, like some basic, like build a binary tree or something like that. So those kind of data structure, bit of data structure, bit of data engineering capabilities should be there. Data engineering doesn't mean that Spark and all, they never ask you those questions. They only ask you basic programming, okay, like pandas, numpy. Questions will be revolving around those things, okay. Now once you clear this interview, the next phase comes the ML part, okay. In this ML, they never ask you that write down a code of logistic regression or write down a code of linear regression. They don't ask you all of those. They ask you scenario based question, okay. They will say that you have a data, and by this they actually judge whether you are an experienced guy or you have anything predefined in your mind, okay, with the data set or with the algorithms. So the ML algorithms that you basically go and apply, you have to be very strategic. You have to be very you need to spend more time in feature engineering, and then you say that, okay, by supporting these features, I'm choosing this algorithm, okay. So these are things you get to learn, like how can you basically go and crack, okay. So simply by learning the algorithm will actually not help you to crack the interview, but rather you need to solve some realistic problem statement that will actually help you to go and crack these interviews, because they never ask you that what is the formula of logistic regression or what is the formula, because everybody knows that you can simply Google it out, you will get the formula. But they ask you why you use logistic regression, why not linear, okay, or what are your objectives, what you achieve using logistic regression. So these will be your questions, which are more strategic and only comes through experience. So one thing you have to understand, that is the data scientist is one of the hottest job that we all know. At the same time, you just need to think from the business perspective. If something is in a very high scale paid job, okay, so they would expect a better ROI from you, okay. If we don't deliver the better ROI, there's no point of this job. Is not a job, okay. It's basically how much value addition you are making to that business. You need to understand that. So simply learning won't help, but you need to also collect the experience from different data set. You need to collect the experience from different industry driven approaches. Then only you will be able to add those value adds. Okay, otherwise it is a non-value add. It will be a non-value add learning, and eventually the interviewer will come to know. Just a minute. So eventually the interviewer will come to know, and you will be not able to, you will be not able to put yourself in a proper justification. So just by learning ML will not help. You need to get the experience of it. Means more than you learn, you need to get exposure with those data, and then get exposure with the problem statement. How do you solve that? Okay. You will be left out with that data without much of your information. You need to really think of yourself. Okay. And you can get the help of the mentor. Okay. You will get the help of the mentor wherever you require. But the idea over here, the way of learning over here is more like you need to think on that problem statement, need to think how can you solve it, and then you need to apply the algorithm. Algorithm comes at the end. It's just a one-liner in Python. Okay, it is so easy, but that doesn't pay you. The one that is paying you is basically the experience. Remember this. Okay, algorithm never pays you because they're already predefined. You know it, somebody else will know. They're systematic in nature. You need to know how to use that. Okay, where to use that, when to use that. Okay, and how to evaluate. So that is what you get paid for. The third thing is deployment. Okay, so most of these machine learning algorithms are deployed in cloud services. They get deployed in different pipeline nowadays. Okay, there are a few new pipelines which are coming up. So some of the product company, they expect you to learn deployment as well. Okay, means just by knowing the algorithm, getting the result will not help. You need to deploy those models in a cloud platform, or you need to deploy those models using any of these MLOps tools. So we are going to kind of get you through that exposure where you get to learn through the MLOps tools. You get to learn how to basically put these things in a deployment phase, and then you take those problem statement, apply the different engineering techniques, apply the algorithms. Finally, you go ahead and deploy. Okay, so there are a couple of tools developed by or designed by McKinsey. Okay, developed by different other platforms. Different production company, okay, like Weight and Bias, MLflow, Kedro designed by Quantplack, McKinsey. So these tools you will come to understand once you start getting into this deployment journey. Okay, so most of the machine learning experts, they really don't. They are good at these steps until this second steps they are good at, but they really lack the deployment capabilities, which is very, very important. Okay, now it depends. Some of the organizations, they don't care about deployment. Why? Because they are a consulting organization, so they need more about the research. They want their candidates to do the research and give the prescriptive analysis of the data. So they don't really bother about deployments. Okay, so you see any consulting company like EY, okay, Deloitte, they don't bother much about deployment. Okay, they are more into a consulting firm, and they basically try to give the research study or material. While the product company, they really need this because they need to integrate with their existing services and the products they are in. So this is how this is the these are the basically the points, okay, where you will be getting more focused, okay, with this course. And apart from that, if you come up talk about the algorithm perspective, so algorithm perspective, we start with all the ML algorithms, like all the regression algorithms, trees, bagging, boosters, clustering, supervised, unsupervised, all the ML algorithms will be covered. The interesting part that in new edition of this course, we are also adding deep learning techniques, okay, where we are covering artificial neural nets, ANN, okay, we are covering deep neural nets, we are covering CNN, convolution neural nets, we are covering natural language processing, NLP, okay. So these are the new dynamics that we are adding to this entire course, which was earlier not there, but yeah, now we are adding it up. Okay, so to give you a 360 view, basically machine learning algorithms are good for handling structured data. Okay, structured data means those which is in a row column. Okay, like your Excel sheet, your CSV sheets, they are structured data. Okay, so machine learning algorithms are good in handling those, but they don't have that capability to handle unstructured data. Okay, like what are unstructured data? Images, videos, languages, okay, recording. These are all unstructured data, right? Music, speech. So machine learning cannot basically handle those. Deep learning algorithms can handle these unstructured data. It can handle different dimension of the data. So that's why deep learning algorithms are bit important nowadays, because as we move on, you see the business is no longer in your Excel sheets. Okay, the business is getting expanded, and it gets into a different dimension now. Okay, your business is not supported just by your sales. Your business is completely being running based upon your advertisement, which is coming from different sources like Facebook, LinkedIn, Instagram. Your business is mostly supported through different social media platforms. You collect all your feedback, customer feedbacks, okay, from social media platforms. So you need to have those dynamic information, okay. You need to have those dynamic capabilities. So then only the business can basically be scaled. Okay. We apply algorithm for what? We apply algorithm for scaling up the overall business, right? So that we don't need to manually sit and do all of those stuffs. If I ask you to manually go through millions of comments, it is not possible. Rather, you will replace that with a AI system which takes all the feedback of your business on a daily basis, on a real-time basis, and immediately gives you kind of an response. Most of you might have seen this application. So for an example, in Facebook, if you just put any comment that, let's say for an organization, you didn't, let's say you went to an Apple store, okay, and you didn't get your product on time, or let's say your phone, you have bought it, but it is not working good. You put a comment on social media. Immediately you get to see a response, right? Thank you. Our team will soon connect with you. Our team will reach out to you. We are sorry for your inconvenience, right? You get to see these messages. So how does these messages are appearing? This is appearing based upon your sentiment analysis. There are different tools which are basically running 24/7 to get you the sentiment analysis. Okay, whenever the comments are getting into a negative state, it automatically shoots this message so that it grabs your attention. Yeah, that Apple has really heard me. But those are nothing but those are all chat bots, sentiment bots that are running. Nobody's hearing you, but it is just to improve the reputation of the brand in a social media, right? And these things are all done with the help of these deep learning algorithms, natural language processing. One of the recent application is ChatGPT. You might have already heard, right? Now, ChatGPT is so potential that it can basically kind of speak on every given domain. So far, natural language processing and generations were domain restricted. Means you train a data on food, your bot will actually speak on food, but it cannot speak about finance. Okay. Now we have designed an algorithm, okay, that basically can speak on any given topic. It can speak on food, it can speak on finance, it can speak on anything without getting connected to an internet. Okay, it can generate its own way of speaking. Okay, let me think. Let me see if I can get you through the demo. Just a minute. Just a minute, guys. Let me just log in with my credential and then I'll share my screen. Yeah. If you ask, can you plan 7 days vacation for me in Kerala? You see, so nicely basically narrates and get you the overall plan. So you can see that every day, on every day, how you should basically go ahead and spend some time. So you can see it is bit stuck. You see that for 4 days uh, it got stuck. But yes, this is so dangerous. Just imagine, okay, that human being can basically, okay, it says your internet is a bit unstable. So human being can, I have one like, let me save and submit. With the help of these chatbots, conversational AI platforms, okay, it becomes very interesting to solve some of these very complex problems.
There, I think the expert has lost his internet connection. Just give me a moment. He'll be rejoining in a while. Please.
Sorry, guys. I got dropped out here. You see, for any given business services, one thing is very important is how you are basically approaching and solving their problem. You see, a lot of customer service centers, right, can be easily replaced by this conversational AI platform. It can be easily replaced. Why? Because it can speak on any given domain. Okay. Even when a customer service or a customer support, they have a particular domain to speak with. So if we replace those people with these bots, just imagine how much disruption will come in the industry. These bots, these chatbots can also solve mathematical problems. So you see, can you solve and solve 9 plus 87 into 90 plus into 90 plus 78. Okay, regenerate. Let me save and submit. Okay, so sometime it's basically this is currently running on a free server. So because of that, it takes more time to respond with. Okay. Anyway, but I hope you got the idea over here. So our idea is um, these conversational AI platforms are very, very powerful, right? And this explains that how AI is growing at a different aspect. This is not connected to an internet, so it is basically learning. It also makes some mistakes. If you see here in this conversation, so this is plan. Okay, it says I was actually going through it. It makes some mistake even, but that is adjustable. Okay. So these are next application overall. Okay, the next gen application of machine learning, deep learning. This is basically deep learning driven application. There is another application which is known as DALI 2, where you can write down something that can be translated into a very images that can be translated into images that can be translated in any given context. This is a text to image generator. Okay. So the things that you see a space, this is the description. The astronaut taking beer, a bowl of soup, riding a horse. Yes. And this is the description, and it got translated into this particular image, right? So this is the next gen of computer vision. Okay, that it's a kind of an AI artist. Okay, right? It helps to basically go and imagine any of your context, and it can basically go and translate to a given picture. Okay, so these are the things that we are going to learn in this overall journey. Okay, we are going to learn many things. I just gave some of the use cases, some of the application, some of the areas that we are a bit focused. Okay, so that we can help you with real data science driven course, not typically any course, but give you a real experience. Experience is more important than a course, because with the help of experience, you will be able to crack those interviews. Okay. Yeah. Anybody, any questions that you have? Go ahead. Any questions, any doubts? You can go and ask. No questions? Okay. What do you, Kunal?
Yeah, thank you, Rishabh. Thank you so much. Guys, I hope you have been gone through a different experience with the data science ecosystem. And hi, I want everyone to unmute themselves, and then so that I can have a bit of an discussion with them. Uh, Guys, we have also designed an exclusively career roadmap in data science for you guys. So I think that is already, we have sent it over the chat window. And I would be more happy if some guys you can connect us and we'll discuss further about it. If there could be anything that we need to discuss, so that it would be great. Apart from the technical stuff, I would be more happy to discuss with the other stuff regarding, like, obviously we're gonna work out with our new uh, program in a while. So we're gonna discuss those. If anyone would be interested, we're gonna discuss those details also with you guys. If anyone would be seriously interested and wants to participate. So anyone has any further queries are there?